Okay. Hello, I am Kristina Sunada, and I am presenting the Stevens Hand Drumming Robot Project. To start off, our project is a little bit different in that we are aiming to combine music and technology. Our focus was on African goblet drums, such as the djembe pictured here. Our aim was to design a robotic mechanism that would combine the very human aspect of hand drumming with modern technology and automation. We started our process with concept generation, where we observed human hand drummers and theorized solutions to produce a robotic mechanism that would simulate a human hand drummer's motion and striking on the drum. Our system architecture starts with a user interface that produces MIDI inputs. These inputs get sent to our electromechanical subsystems, which consist mainly of two different motor systems. Starting with our user interface, we designed it like a classic music sequencer, where each column represents one note in the rhythm. The user is able to select different dynamic levels, which are represented by the three different colors on the music sequencer. This user interface is stored on the Raspberry Pi and produces MIDI inputs, which can be saved and re-uploaded. These inputs are sent to two different Arduinos. Each one controls one of the motor systems. Delving into the mechanical systems, we have a dynamics, a rhythm, and a striking mechanism that I will go into. Starting with the dynamics, we determined that the best way to control the dynamics on the drum surface was by controlling how hard we were hitting the drum surface. We did this by adjusting the top bracket with a cam and follower mechanism. At the top position, the striking hand would very lightly hit the drum surface, producing a quiet sound. At the bottom position of the cam, we would be hitting the drum with much more force and would produce a louder sound. Our rhythm control was determined with a 4-bar linkage. We used a 4-bar linkage in order to have a very specific path of motion that would mimic the striking path of a human hand when playing the drum. The two main aspects that we focused on were coming down hard and fast onto the drum surface and then lifting up quickly in order to allow the drum surface to resonate properly with the strike. Finally, our striking mechanism. There are three main notes that are played on the djembe drum. And so we designed three different striking hands with individual characteristics based off of which portion of your hand would be striking the drum for each of the notes. We used layers of silicone and foam in order to mimic the elasticity of your human palm or fingertips bending on the strike. Additionally, our striking hand was connected to the rigid 4-bar linkage using an elastic joint. This allowed us to distribute the force over the drum during the striking, and it also ensured that we would not be damaging the drum surface at our loudest dynamic levels when we would be hitting the drum surface quite hard. And here I have a video demonstrating the mechanism. I'm not sure if the sound will work, but we will at least be able to see the motion. As you can see in the video, we were able to demonstrate three different dynamic levels on each of the three striking hands, just as a demonstration of the capabilities of our mechanism. For future progress, we are looking to have this project be developed into being used with different kinds of goblet drums, such as the darbuka and the doumbek, which are from more Middle Eastern areas instead of Africa. And that is the presentation. Right. Thank you for watching, and we would be happy to answer questions during the poster session.